Hello everyone, we are going to look at integration by parts one more time. I hope that you have had an opportunity to practice, and did you find that there were one or two problems within the practice that were a wee bit tricky? Well, let's look at one of these problems. I have e to the 3x times the cosine of x here. So you know that we like to pick a u value where the derivative will make a simpler problem. And we like to pick a dv value where the antiderivative is not very hard to do. So as I look at e to the 3x, I can find a derivative, but it won't make it simpler. I can find the antiderivative. That's not a problem. And I look at the cosine of x. I can find a derivative, but that doesn't make it simpler. And I can find the antiderivative of the cosine of x without a problem. So this is a special one. Let's see what happens. It does not matter which value you choose for u and dv. So I will choose u to equal e to the 3x, and dv is going to be my cosine x dx. All right, with that, du is going to be 3e to the 3x dx, and v is equal to the antiderivative of the cosine, which is your sine of x. Now we use our u times v minus v du, and we will see what we end up with. So an equivalent expression will be e to the 3x times the sine of x minus the integral of 3, let's pull that 3 out front, e to the 3x times the sine of x dx. All right, so as you look at your problem again, notice we have an e to the 3x sine x. Again, we didn't make the problem easier, but we also didn't make it more difficult. So again, I'm going to let u equal e to the 3x, which leaves me with dv is equal to the sine of x dx. Okay, so du will be 3e to the 3x, and v is the antiderivative of the sine, which is going to be the cosine of x with a negative. Hardest part about this problem is making certain you do not make sign errors. So this equivalent expression is e to the 3x sine of x minus 3 times u times v. There's e to the 3x cosine x, but that has a negative in front. Minus a negative makes it positive. The 3 times the integral e to the 3x cosine x dx. Right, so now, okay, we could do it again, right? E to the 3x cosine x. We could start all over again and just keep doing u equals dv equals over and over and over again, and we will get equivalent expressions. But you are a thinking person. Notice this e to the 3x cosine dx is the same expression I started with. Matter of fact, we don't often think about what's happening on the left side of these equal signs. The integral e to the 3x cosine x dx is equal to this expression that we have just created. With that in mind, let's do a little bit of algebra. e3x sine x, distribute my negative 3, gives me plus 3e 3x cosine x, and I will have minus 9 integral e to the 3x cosine x dx. Now, do some algebra. If I add 9 integral e to the 3x cosine x dx to both sides of this equation, do you see where I'm going with this? And I've got my 9 e to the 3x cosine x dx. Okay, so on the left side, now I have 10 integrals e to the 3x cosine x dx. And that has to be equal to e 3x sine x plus 3 e 3x cosine x. And then wait, if I divide by 10, I now have the expression that I'm looking for. And we know that the original problem, the integral e to the 3x cosine x dx is equal to e 3x sine x plus your 3e3x cosine x over 10, and don't forget your plus c. So I saved this problem for lesson 7, just because I wanted you to have a little bit of practice solving problems using integration by parts. Now, your lesson follow-up. Go ahead, practice integration by parts a little bit more. Have a great day.